Welcome back, coders. In this tutorial, we'll see how to achieve the solution for estimating the speed of the vehicles using Ultralytics. For this purpose, we'll be using Ultralytics package and ready to use wrapper which will help us to ensure this result. I mean the speed, to estimate the speed of the vehicle in a very short and very step-by-step easy process using Ultralytics and the dependent wrappers and packages. So what it will do is it will estimate the speed of the vehicles using the pre-trained model. So we won't be training the model right now, but we'll be using the pre-trained weights of the YOLO model, and we'll be testing the speed of the vehicles on which the model is already trained. So as you can see in this video, and this is a random video downloaded from YouTube where these are random vehicles, car and probably this truck and all. So the model YOLO V8 or YOLO V9 is already trained on these type of vehicles, so we want to use that right now and we want to implement the speed estimation task. So in this tutorial, we'll see how we can ensure this by specifying a particular line point. So this is a line. So what we'll do is we'll tell the script that when the object crosses this line, so basically this is the centroid point. So when you do tracking of your object, so tracking is done and it is ensured maintain the history of each tracker ID, and there is a centroid point. So basically when the centroid point moves on this crosses this line, then at that point the script or the model will perform the speed estimation and it will show the result. So you can see this particular car is now crossing this or just now crossed this line, and then the speed is estimated and it's shown plotted here. But this car has already crossed, so it's not happening right now, so the speed will not be shown. So basically through this you can specify a particular area. So probably if you want to specify that okay, you want to estimate the speed of the vehicle in this lane or in this lane, or probably in just this part of the car, or probably just this road, or probably just this part of the road. So basically you can specify region or a line or a particular area where you want to estimate this speed. But for today's tutorial, I'll make it very simple and I'll just estimate it using area in form of line. So basically when any vehicle will cross that line, it will perform speed estimation. So let me play the output video the way we want to achieve the result. So it's reflected, and now when this car has crossed this line, so basically this centroid, then it has estimated the speed of the car. So it's very simple, but obviously this is the basic thing, and you can achieve as per your use case by modifying the area, modifying the line points, modifying the region points based on your requirement and based on the size of the output video. So how this line has been defined? This line has been defined depending upon the size and resolution of the video. So this is the first coordinate, so this is the x1 y1. So basically this is the x1 point is here 0 and y1 is the y coordinate divided by 2, and this is the last point of the x coordinate, and same y for y divided by 2. So similarly you can do it like, suppose if you want to put here to here or just till here to here, so you can change it as per the dimensions of your video. So let's get started and jump into the code. So the first step will always be the same because we want to use Ultralytics package. So from Ultralytics import YOLO, right? And then there is one new import. So Ultralytics is in Ultralytics we can use solutions which has the speed estimation script that will help us to directly use the speed estimation module and integrate it with our solution. So you can do from Ultralytics, which should be already installed on your system, or if not, you can install it by pip install Ultralytics or hyphen capital U. That means if you want to install the updated version, so you can do pip install hyphen capital U Ultralytics. So from Ultralytics.solutions, import speed estimation, and then import CV2, because obviously if you're working with images, videos, writing, showing, etc., so you want to use CV2. Then comes the importing model. So when you have imported YOLO, so you can just specify the name of the weight file. So right now I am just showing by importing YOLO v8n.pt. You can also write YOLO v9c.pt or any of the weight file, but please ensure that do not use very heavy model. Use a very lightweight model, because the speed result in form of speed, that means the speed will depend upon the size of the first of all processor. So be it like if you're using or estimating on CPU, or if you are estimating on GPU. So depending upon your processor speed, the speed estimation will vary. Also, the size of the model will also impact the speed. So make sure that you are using the model and the processor which should be very much similar to when you'll be using in the real time or with the video. So yes, so that in short, the result of the speed, that means speed which will be achieving, won't be that accurate, but it will be close to it. So when you have imported specified the name of the weight file, you can pass it into a variable. Now if you want to show the name of the classes, so you can directly put that model.model.names. so it will contain all the classes which is being detected, and you can put it inside this variable. It's not very necessary for this purpose. If you do not want to show the names of the classes, you don't need to do this. So it will basically depend upon how you want to visualize your results. So you can just change it. That's not very hard and fast to do that. And then again this is the very basic thing. CV2.video capture, then you can pass the name of the video on which you want to estimate the distance, so estimate the speed, right? So I have a video named vehicle.mp4, so I have put the vehicle.mp4 file name here. If it is in somewhere else, so you need to specify the whole path, but right now there is one folder I have created. Inside that there is this script which is open, and then vehicle.mp4 video. So it's directly written that. Then we want to check that there is no error in the reading the video files. Assert cap dot is opened, and then we want to read the height, width, and fps, that is frames per second of the video. So we can do it by CV2. So first of all, integer, then cap, that is instance created while reading the video, dot get x for x in, this is CV2's functions, cap prop frame width, cap prop property frame height, and then cap prop fps. So this is the predefined CV2 functions. Now we also need to specify how we want the output video to be. So basically here for reading the video we are doing CV2.video capture, and for writing the video we'll do CV2.video writer. Now you need to specify the name of the video, which should be the output name of the video. So I want my output video to be named as speed_estimation.avi. Also, depending upon the OS you're using, you also need to specify the video codec. So I am using on macOS, so I am using star mjpg, and then you want to specify the fps and height width, which we have. So I will keep it same which was there while reading the video. Now this is the main and very important part, specifying the coordinates of the line, and that I have explained while starting the video. Like basically when the object is detected and being tracked, and then we can specify a line, or we can specify a region, so that when the object is crossing that line or object is crossing that region, then at that moment or at that area we want the model to estimate the speed. So this size of my video was one I can show you. It's 3840 by 2160. So this is the length and this is the width. So I want the line to be like this. So this is the 0x1 and this is the y1, this is the x2 y2. So x1 is 0 and y1 is 2160 by 2. So that means 1080, and this last point should be the last x coordinate, that means 3840, and y is the same, y by 2. So 3840 comma 1080. Similarly, if you want to specify a region or line to somewhere else, you can change the points or the region. So yes, and this is the very important part. And then we want to initialize the speed estimation. So basically, for this purpose, we'll be using the speed estimation which we have imported, and speed estimation has speed estimator function. So directly use that speed estimation dot speed estimator and put it inside this speed any variable. So I have put it inside the speed underscore object. Now there are few arguments, and there are few arguments you can change, and there are few default values as well, but right now I'm setting 3 arguments. So speed underscore object dot set args. First of all, what is the region point? So basically, at what region you want your model to estimate the speed. So I want at this line point, so when the object is crossing, so then estimate the speed. So region points equals to line points, names equals to names, because I want the model to show the names of the detected object as well, like here when we have imported the names from the model. And then view image equals to true. So that's very simple. And then the same thing while cap is open, like when the video is being read, when video is open, then success and this image instance equals to cap dot read. And if not success, suppose if there is an error reading frame or something happens, or if suppose the video is completed, so then break, or else first of all we'll do tracking. So tracks equals to model dot track. So simply we know that because when we want to perform something on a video and we want to maintain the history or maintain the stream wise information, that we want to perform tracking, right? So you can use default tracker, you can use the other tracker also, but right now for this tutorial I am using the default tracker. So we have the model instance here, so model dot track, and then we'll pass the 1 by 1 frames, that is IM0. We also want to do persist equals to true, because we want the model to maintain the frame wise information. So basically we want the model to know that there is a relation between n frame, n plus 1 frame, n plus 2 frame, or n minus 1 frame, and then show equals to false. After that, when we have all the tracking information, what we can do is we can use the image, that means the frames, and then the tracks, that means the tracker, and then we can directly use the speed underscore object variable, and it has one method, estimate speed. So we'll be using speed underscore object dot estimate speed, and we'll pass 2 things, the frames and the tracker information, and then we'll pass these informations to be written inside the output video. So video underscore writer, which is here, dot write, and then the IM0, and then cap dot release, video underscore writer dot release. Then we can run this script. So for that you can directly do Python and then speed estimation dot py, and then you can see, yeah, and then this video will appear, and you can see this is the centroid, and when it will cross this line, it will detect and estimate the speed. The speed is 14 km/h, and you cannot see the speed of this object, because when the video started, the car was already has already crossed the line. So the model did not know that there is the object which has crossed. So there is no speed on it. So basically when a object will cross this line anywhere here, then only the speed will be estimated. If it has already crossed, and then it won't. So yes, so that's why there's no speed here. Like you can see this card is coming towards the line, and probably this is the centroid. When it will touch this line, then the speed will be estimated. So just 1, 2, and then 3. Now the speed is 7 km/h. Also, you can see here that this is how it will show that the number of total objects. There are 2 objects, 2 cars. If they are 2 different objects, so it will show 1 car and 1 truck or all that. The time taken, to detect the object. So this is the way it will show, and then finally it will save the output with the, like I have specified this speed estimation .avi, so it's the speed estimation .avi. So basically let me stop it, and then it is stopped. So basically there are 2 ways of doing it. First of all, we can on the CPU and GPU, or if you want to use the speed estimation, either you do it directly by we all know it, like for estimating the speed we need to measure it by Euclidean distance, and like from Ultralytics, where we have imported the solution and speed estimation a script which has this speed estimator function. So there it is already done. So the Euclidean, on the basis of Euclidean distance, this all thing has been performed and calculated. But if you want to have a look and see where you can understand the whole detail, and if you want to implement it, and if you want to understand it how it is happening, so then let me show you. Yes, so as I have told you, we are importing from Ultralytics. So from Ultralytics.solution, so .solutions, and then there is speed estimation. So this is the speed estimation Python file, where the whole process of speed estimation using Euclidean distance has been performed. So if you want to understand it and know it, how it is happening, what all details and the way it is happening from the scratch, and from the very deeper level, so you can come here in this Ultralytics GitHub repo, and then you can understand each and everything. So but my aim was here to let you and help you in achieving this task of estimating the speed of the vehicle in a very simple and straightforward way, using the very less code and using the very less time, like in a very efficient way. But if you want to go deep in it, and if you want to try and do hands-on different ways, probably if you want to test it on depending upon the various models, so probably you can use here, like in the code you can use YOLO. Instead of YOLO V8, you can use YOLO V9, and you can see on the same test video, you can see how it affects the result. Or if you want to analyze based on the region, so instead of line points you can provide 4 coordinates, so probably region. And similarly, you can, instead of providing a region of a whole video or with the same length, you can change the length and width, and you can change the location. So probably the region should region maybe the 2 lanes or a part of lane. So you can play with it, and if you want to know and do it by yourself from the scratch, then also you can do it. So this tutorial was aimed to give you a path where you can see how you can use the existing codes, and you can play with any form. Like if you want to interested in seeing the speed, I'm not the speed estimation like the speed, but depending upon the speed of the model, how it depends upon the size of the model. So you can compare various models, or you can compare the results based on how you're changing a region, or and there are different ways. So I hope this tutorial has provided you a basic and a way where you can go and look forward and have the basic information and the basic idea of how to use it and how to get and achieve the result. So if this video was helpful to you in any form or any way at any point, I feel myself obliged. And if there is any question or any query or any any doubt or something, please feel free to comment in my comment section, and stay updated with my upcoming videos. Thank you so much.